Hey guys, in this video, I'm going to go over progress check C and kind of explain the questions that are in there. So question number 7, we have a table and it gives values for the function f. Based on the data in the table, which of the following could not be the graph of f on the interval from 2.9 to 3.1? So basically what you're checking to see here is just that the values match up. I mean, pretty simple. You can also check the limit at x equals 3 for the table and for the graphs and make sure that they're all there. So the limit as x approaches 3, if you're looking at the table, if you look from the left and from the right, it appears that it's approaching 3. So do any of the graphs, does it seem like any of these graphs right here, where the limit does not approach 3, does not approach 3 at x equals 3? Okay. Question 8. So we have a piecewise function, it looks like, and let f be the piecewise function defined above. Also shown is a portion of the graph of f. What is the value of the limit as x approaches 2 of, look, we got ourselves a composition here. Okay, so make sure that you follow those rules, those steps for the limits of compositions. Evaluate the limit as x approaches 2 of f of x. Now you will also have to note that as the limit approaches 2 of f of x, approaches 5, but also you can see that it approaches 5 from above and below. But that shouldn't really matter. You should just be able to consider the limit as x approaches to the limit as x approaches 5 of f of x, because we don't even have a graph. The graph isn't even shown at x equals 5. You have to use the function up here. You have to use the piece of the function 6 minus 1/2 x, because that's how the graph is defined at x equals 5. So yeah, but yeah, just follow the rules for compositions and that should get you in the right place. Just know that you're probably going to have to use some substitution instead of just evaluating a limit from using a graph. Okay. The table above gives select values for a function f. Also shown is a portion of the graph of f. The graph consists of a line segment for x is less than 3 and part of a parabola for x is greater than 3. What is the limit as x approaches 3 of f of x? So I think this one should be pretty. Can I use the table? The limit as x approaches 3. Yeah, I guess you can say that you can use the table. One thing I would note is that it does appear to exist, so it's not D. It doesn't look like it's going to be 2, because that's what the function looks like it is, so I wouldn't say it was C. So either you can say it's between A and B. Now, what you could do right here is that you see that line segment right there, right? So the line segment for x is less than 3. The thing is, you have points of this line, right? So if you have points of this line, you can take 2 points right here, and since I have at least 2 points for the line segment to the left of 3, I can find a linear equation that gives me both the slope and it gives me the y-intercept. So if I can find an equation for that line, I don't have to guess. I can actually take that function and plug in 3 to see what it would be. And so if you don't really know how you can do that, I would look at my solutions, the key for this, because I think I do that in this problem. So you can check and see how I find the equation for that line to the left of 3. Again, I just picked you can pick any 2 points, and we have them from the table, and you can find the slope between those 2 points, and then you can work your way to find the y-intercept, which means you would have the equation for your line, and then you can just plug in 3 into that equation, and then yeah, you should be able to get your answer like that. So a bit more tedious work on this one, if I'm being honest. Kind of sucks, but kind of that it just happens. All right, next question. So the function f is defined above. Which of the following statements is true? So what I would do here, if I'm looking at this right here, I would factor the function on. I'd factor the numerator. See if you can factor that, which I think you can. So what? Yeah. So look at how you can factor that, and see if you can cancel out that x minus 3. If you can, that means that there's a removable. If you can't get rid of that x minus 3 in the denominator, that means it has to be a vertical asymptote. I can't see where this would be a jump discontinuity. I don't think that's going to be the case. Now, I guess you can also consider that it still could be continuous at x equals 3. But again, you would kind of have to see if you can factor that numerator there, cancel it out, and if that function, if you were to plug in 3 into that function, if it would be equal to 9, as it is in the second piece of this piecewise function, then it should be continuous. So I'm going to say that it's probably going to be A or B, or D, I guess. You just have to check and see if that x minus 3 can be canceled out with a factor in the numerator. Okay? The next one, the function f has a removable discontinuity at x equals 3. Which of the following graphs could be the graph of f? I think I'm going to let you guys do this one. This next one, the graph of a function f is shown in the figure above. At what values of x does f have a jump discontinuity? Again, I think this is something that you guys can handle. You're just looking at which x values has a jump discontinuity. The next one, the limit as x approaches 6 of f of x exists where the limit as x approaches 6 of f of x is less than 8 and f of 6 is equal to 12. Which of the following statements must be false? So going through each of these right here would probably be just the best thing to see if it matches up with the description. So the limit as x approaches 6 from the left. So the limit as x approaches 6 from the left of f of x is equal to 0. It could be that because it does say that the limit as x approaches 6 exists. So if the limit as x approaches 6 of f of x exists, then the limit from the left and the limit from the right are going to be the same, right? And then it says that the limit as x approaches 6 of f of x is less than 8. And 0 is less than 8, so it could be A. Which of the following statements must be false? We're not saying that it is 0, but it could be 0 according to the what we're given, okay? The limit as x approaches 6 from the right of f of x is less than 8. Well, yes, because the limit exists and the limit is less than that. So that could, yeah. So C, the limit as x approaches 6 from the left is equal. Yes, so C has to be true because the first thing that this statement says is that the limit as x approaches 6 exists. So I kind of already said that earlier. So I kind of just did this one. So D, f is continuous at x equals 6. Okay, that must be false. Yes, because it says that the limit as x approaches 6 is less than 8. But it also says that f of 6 is equal to 12, which is greater than 8. So therefore, it can't be continuous because those values would be different. So there you go. Okay, this next one, let's see what we've got. So let f be a function defined above. Which of the following statements is true? So it looks like the answers here are looking to see if it's continuous. Okay, so if it's going to be continuous, then you have to see that the limit from the left is equal to the limit from the right, and that the value at f of 1 is also going to be the same. So I'll let you guys take a look at that. Pay attention to the inequalities there in the piecewise function. Okay, see if you can find an accurate conclusion here, as well as a reason. So you have to make sure that the reason is correct. Okay. For the next one, which of the following functions is continuous at x equals 3? This one might be a little tedious. You just have to go through and check these. So you have to check A, B, C, D. C. You have to make sure that the limit from the left and the limit from the right is equal to the same thing as what's happening at. So for A, for example, so you see how f of 3 is equal to 8. Okay, that means that the function above it, now from the left side and from the right side, the limit of that function has to be equal to 8 as well. So do some factoring on the numerator, see if you can cancel out the factor on the denominator, and see if you can plug in 3 to make sure that it's going to be equal to 8. And if it is, then it's continuous. If it's not, then it's discontinuous. Okay, so you're just going to go through all these and check those. Okay. All right. Let's see what we got next. So we have a calculator required question. So let f be the function given by f of x is equal to this right here. Which of the following open intervals is f continuous? Okay. Now I think I would just do this one by hand, to be honest. Okay, so you see that x squared minus 2 on the denominator? That can be factored. You can factor that into a difference of squares of x plus the square root of 2 and x minus the square root of 2. Okay, so, or you can even use that little trick that we've been using from before, right? So if you think about can you use that? I don't think you can use my trick because x squared minus 2 is not a linear factor, so maybe not. But one thing I would note, so if you factor that, I don't think there's any need to use a calculator here, to be honest. So factor that x squared minus 2 on the denominator. You get x plus the square root of 2, and you get x minus the square root of 2, right? And then from that point, at that point, you can see that x could not be equal to plus or minus the square root of 2, and plus or minus the square root of 2, and that's the same thing as plus or minus, like, what, 1.7 something if you do that. Okay, and then you can also see that there's going to be a hole because you have a factor of x plus 0.4 in the numerator and the denominator. So there has to be a hole at x equals negative 0.4. And so you have all three of these values. You have x equals plus the square root of 2, x equals minus the square root of 2, and x equals negative 0.4, where you have domain restrictions. And so those are values where it's not continuous. So f is going to be continuous on one of these intervals where none of those three values don't exist. Okay, so that's what you're looking for. Which of these four intervals does not include negative square root of 2, positive square root of 2, or negative 0.4? That's what you're looking for here. Okay, the next one, also calculator required. This one does look like you're going to want a calculator. So this one will be similar to what the calculator required problem that we did in the homework. So let f be a function defined above. For what values of b is f continuous at x equals 3? So if these functions, if these two pieces of this function, if there's going to be continuity at x equals 3, then they have to be equivalent at x equals 3. So you have to plug in 3 for x to both of these right here, and then you're going to have to graph both those functions, and you're going to have to see where they intersect. Looks like it could potentially intersect at 2 different values, so make sure you consider that, but you're just using your calculator to graph these after you plug in x equals 3. So for example, you plug in 3 into the top one, you get e to the 3b. Plug that into your calculator as e to the 3x. And then on the denominator, you're going to have to plug in 3 right there. If you plug in 3, you're going to get 2 plus b. So in your calculator, in the graphing part, plug in 2 plus b, graph these two functions, and see where they intersect using your calculator tool. Okay? The graph of f is shown above. On which of the following intervals is f continuous? So yeah, just check these intervals. So like 0 to 1, and just make sure that there's no discontinuities in there. So I'll let you guys do that one. Okay, moving on. Let's see. So the function f is continuous on the interval from -2 to 5, and is not continuous on the interval from -2 to 5, including those. So that's the difference between these two intervals, is that they're including these endpoints when it's not continuous. Which of the following could be an expression for f of x? Which of the following could be an expression for f of x? Could not be. Okay, so that is an important distinction. I remember doing this one and getting kind of tripped up because I didn't read the question correctly. Which of the following could not be an expression? So make sure you watch out for that. Okay? Basically making sure that none of these, that the domain restrictions in these right here, that's what you're checking for. Okay, moving on, let g be the function defined above where k is a constant. For what values of k is g continuous? Okay, this is the same thing as we just talked about with the calculator one. You got to plug in -2 for x, right? And then, well, maybe first, on the numerator there, no, on the expression x squared minus 4, that can be factored into x plus 2 and x minus 2. And on the denominator, you can factor out f4, and you'd get x plus 2. And then, it might even be easier at that point. You can plug in -2 and see what would have to be the value of k. So, yeah, see if that does anything right there. So pretty much just like factor, simplify, plug in, and see what value it would have to be. Okay, looks like there's a removable discontinuity, and you're just trying to see what that value would have to be. All right, and then we have let f be the function defined above. For what value of c, if any, is f continuous at x equals 3? Okay, so note here that the function is defined at x equals 3. The function at x equals 3 is 7, yeah? And so the function above it would have to be equal to 7 if you plug in 3 for x. So plug in 3 for x, and then you have to set that equal to 7. It has no other choice but to be 7, and solve for c. Do the same thing for 2c plus 5x. You can plug in 3, okay? And then set that equal to 7. And then basically what you have to make sure is that you get the same answer for what you did for the top function and what you did for the bottom function. You have to get the same value of c. And if you don't, then there's a problem. But see if that works. Or another alternative, what you could do is if you plug in 3 into both the top and that bottom one, and then you can plug in these. So for example, you can plug in -4 for, so option A. If you plug in -4 for c, and you plug in 3 for x, do you get the same answer? And then you can do the same for 7. You can do the same thing for -15. So you can check your answer that way. So that could be one way of doing this problem. Okay, it might take a little bit more time because you're checking more, but definitely an option. Okay, all right, and that wraps up this video for Progress Check C.